Let's begin. Today's May 29th, 2024, and we're doing the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's go to turingmachine.info for the details. So the 5 criteria cards that are used in today's puzzle are 2, 7, 8, 19, and 21, and uses the orange verification cards. Notice above you've got your unique identifier for today's puzzle that you can always go and search on turingmachine.info. Let's go solve. So in our grid above we've got our 5 criteria cards. On the top row we've got criteria card A, criteria card B, criteria card C, and in the bottom row we've got criteria card D and criteria card E. So look at criteria card A, and that card will let us know a little bit about our first digit, the triangle digit, as it compares it to the number 3. So should the value of the triangle digit be less than 3, equal to 3, or greater than 3? Criteria card B looks at the last digit, the circle digit, and will let us know whether that value is an even digit or an odd digit. Criteria card C looks at the 3 codes and will let us know how many of those should be a 1. Should there be no 1s? Could there be 1, 2, or potentially all 3 of them be 1? Criteria card D will take a look at the first 2 digits, triangle and square, and add those values up and compare it to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E will let us know whether there is a pair of digits in our 3-digit code, as in the example 131, or alternatively, it has no pair, which means that it could be either have all unique digits, as in the example 134, or maybe even a single digit repeated 3 times. Remember, today's objective is we're trying to find this unique 3-digit code that meets all of the above criteria that we just described. And we're going to start off with our proposal of 314. So the first thing I'm going to do is I'm going to test criteria card B and see whether that last digit is an even or an odd. Okay, so the Turing machine responds that it does not approve of the value I have in my proposal. So notice that my circle value is even. The Turing machine is basically telling me, no, it's not even. Indeed, it should be an odd value. So I'm going to write that down in my notes for section B, that circle is an odd digit. And since it is odd, that means I can cross out all of the even digits for circle. Okay. Next, I want to see whether I have a pair of digits or not. So I'm going to test criteria card E. Okay, so it also does not approve of my proposal of 314. Notice I do have all unique digits, 314. So that means that not having a pair is invalid. So in fact, there should be a pair. So that's what I'm going to write down in my notes for criteria card E, so that there should be a pair. Okay, so obviously I do already know I have an odd, so it could be that the odd got paired up, or potentially the top 2 could be even, and it gets paired up. We just don't know at this point. Let's see. So I've not found out what triangle is, or how many 1s, or the sum. I think I'm going to test criteria card D to see if I can get a better feel for what triangle and square should be. So I'm going to test criteria card D. Okay, so in this case, the Turing machine does approve. If we go back to our proposal of 314, if I add the 2 first digits, triangle and square, I get a sum of 4. That means that the Turing machine is letting me know, yes, the sum of your final solution should be less than 6. So that's what I'm going to write down for my notes on section D here. So that triangle plus square should be less than 6. Okay, so that does it for our 3 Turing tests for each proposal, for each round. So I'm going into the phase where I'm having to construct my second proposal. So let's kind of discuss what we have. So we know that the sum of triangle and square has to be less than 6. So technically, that means that neither triangle nor square could be a 5, because 5 plus anything is either 6 or greater. So I can eliminate the 5s. So at least we know that the 5 cannot be paired up. So if there is a 5, it's going to be just for circle. Let's see. So we should be able, let's see, so we haven't tested criteria card A nor C. So the number of ones and what triangle could be. So we don't have an indication of what triangle is, even or odd, but we do know that when we add it with square, that sum should be less than 6. So let's kind of play a little bit of a thought experiment to see if indeed triangle and square are paired up. It couldn't be 4, 4, and it couldn't be 3, 3, because those both of those add up to either 6 or greater. So the only pairings we could have, if again indeed triangle and square should be paired up, is 1, 1 or 2, 2. So if that were the case, I don't believe that could be plausible, because both of those happen to be both less than 3. So I wouldn't be able to necessarily distinguish, let's see, between 1, 1 and 2, 2. Let's see, 1, 1. So we know there's a pair, so we know it can't be all ones. So it would have to be 1, 1, 3 or 1, 1, 5. And there really isn't anything that forces circle to be either 3 or 5. At least not if it's 1, 1, right? So there's nothing there to really force circle to be one of those values. But 2, 2, 1 is plausible, because we do have this criteria card that will let us know how many ones there are. So it could be 2, 2, 1. Especially if we test it and it says, yes, there's a single 1, then that means that you do have a pair, right? That would mean that the triangle and square is a pair. So that's a viable solution, 2, 2, 1. Again, that's if it's paired up. Otherwise, the only other pairing could be triangle. Oh, no, I take that back. It could be either triangle, circle, or square and circle, except for 5. So triangle, circle, or square, circle. Either way, yeah, it's going to be 1, 1 or 3, 3. Now the question is, if it is square and circle, the only thing that we could, I guess, definitively know about triangle is either it's 3 or 4, not so much 1 or 2. Well, unless it's 2, 1, 1. But yeah, 1, 1. Yeah, 2, 2, 1, 1. Yeah, so 2, 1, 1 and 2, 2, 1 seem to be the current candidates. If it's 3, if triangle were 3, and perhaps there are 2, well, yeah, 3, 1, 1 also seems promising, especially if this returns that you have 2 1s. We know that there can be 3 1s because we do have a pair. So in that case, yeah, it seems like, well, now that I say that out loud, it looks like 2, 1, 1, 3, 1, 1, 4, 1, 1 might not be, well, let's see, triangle will let us know for sure. So no, there are ways to distinguish. And so that may be it. So let's do this. I'm gonna try 3, 1, 1. Let's go ahead and try 3, 1, 1. All right, so let's go ahead and test. Let's test the number of 1s. So again, we know that there can't be 3 of them. There could be even no 1s. Honestly, I had not even considered that. Okay, well, let's go ahead and test C. Okay, yeah, so it does not approve of my 2 1 digits. So again, we know that there are no 3, can't be 3 1s, and there are no 2, so it's either there is a single 1 or there isn't. So let's go ahead and update our notes for C. There are either no 1s or a single 1. All right. And let's go ahead, I guess, and test criteria card A. Okay, so luckily we did get that. So we know for a fact that triangle is a 3. So let's go ahead and write that down in our notes. So we know that triangle is equal to 3. And so let's actually cross out everything but 3. So I'm going to make this small adjustment. And so when we cancel everything but 3, we'll sort of reevaluate and see what our potential options are. Okay, so we still do have one more test, and well, actually, so let's do this. Since we know that the sum of triangle and square has to be less than 6, we know square can neither be 3 or 4, because 3, 3 gives us 6 and 3, 4 gives us 7. So that means we can eliminate 3 and 4. Okay, and so since we know that there aren't 2 1s, we know that it's not square and circle that are getting paired up, right? Because that would be 2 1s, and honestly, square and circle can never be paired up because there's nothing to pair up. One is canceled in either square or circle. So that means that triangle has to be paired up, and so that means that we have 3 for triangle and 3 for circle. The question is, what would square be? Oh, well, a single, well, actually, we don't know. It's either going to be a 1 or a 2, and unfortunately, that means we have to do a third proposal. There's no way, I think, that we can guess what square can be 1 or 2. So unfortunately, we're going to have to test C again, which means we have to do one more round. That's the worst case scenario, so to speak, because you kind of aren't able to use your third test in a round and forcing you to do an additional round. So yeah, I don't see any way to kind of guesstimate between 1 and 2. I don't see any other clue where we could deduce whether there should or shouldn't be. Okay, so yeah, so let's go ahead and test 313. Oh, okay. So I'm going to do a new round, and it's asking me for my new proposal. I'm going to say 313, and the only thing I have to test is C to see how many ones there are. Okay, so it did not approve of the single one, so that means there are no ones. So let me get rid of the word either here, and also the or. So there are not a single one, not a double one, and of course there weren't 3. So that means that my solution is 323. So let me go ahead and cross out my single one here, and cross out my single one here, and interesting, how can I get rid of that 5? That is interesting. That is a bit peculiar, why there's a lingering 5 there. Well, I guess you can cross it out because the 3s are paired up. I don't know, I have to go back and investigate what ultimately decides to cross out the 5. I guess just saying, hey, this is a 3, therefore it can't be a 5. So I'm proposing that my solution is 3, 2, 3. And of course I know triangle is a 3, that's correct. Circle isn't odd, it is. There are no ones, and of course neither 3, 2, or 1. So there are no ones. So that means, yeah, square can be a 1 and circle can be a 1. And the sum of the first 2 are less than 6, and there should be a pair. So everything looks good. So let's go to turingmachine.info and verify our solution of 323. And let's verify. Okay, fantastic. So we got the result we wanted. Unfortunately, because we had to take that extra round, I feel that the Turing machine might have beat us this time around. But let's go ahead and check. So in the first round we did B, D, E. So let's go ahead and do that. So we did B, D, E, and I believe D was the only correct one in that turn. Yes. And then we did AC, and we did C twice in the second turn, or the third turn. So AC. So A was correct, C was incorrect, and in the third round, it was also incorrect. Let's see how we did. Yeah. Oh, okay. So even though we made the same amount of questions, 6, it did take us 3 rounds as opposed to 2. So the Turing machine, that's kind of the tiebreaker between the number of questions asked of the Turing machine, is how many rounds did you do it in. Unfortunately, because of my choices, I did have to do a third turn. Okay, well, lesson learned. We'll have to see how that modifies our strategy going forward. But if you do have a comment, please share with us and let us know what you think. If you like the video, give it a thumbs up. If you want to be notified for the next video, make sure to subscribe. Okay, until next time, have a good one.